question, we have to evaluate the integral dx upon x plus 4 minus x square using the substitution method, and the lower limit is 0 and the upper limit is 2. Let's begin with the solution, and we have to evaluate the value of this integral. We know that ax square plus bx plus c can be written as a into x plus b upon 2a whole square plus c upon a minus b square upon 4a square. Therefore, here x plus 4 minus x square can be written as minus x square plus x plus 4, and this can be written as, taking minus sign common, x square minus x minus 4. Now using the right hand side, here the value of a is 1, so we have minus x plus b upon 2a, here b is minus 1, so we have minus 1 upon 2. A here is 1, so minus 1 upon 2, and then we have whole square here, plus c upon a, c here is minus 4, a is 1, minus b square, b is minus 1, so we have minus 1 square divided by 4, and this is equal to minus of x minus half square plus minus 4 minus 1 upon 4, and this is equal to minus of x minus half square. On solving this, we get minus 17 upon 4, so we have minus of 17 upon 4, and taking this minus sign inside, we have 17 upon 4, which can be written as square root of 17 upon 2 whole square minus x minus half whole square. Therefore, if the given integral, we suppose this is I, then I can be written as integral of dx upon square root of 17 upon 2 whole square minus of x minus half whole square, and this is from 0 to 2. Now, let us suppose that t is equal to x minus half. So, on differentiating both sides with respect to x, we have dt is equal to dx. Now, when x is equal to 0, then t is equal to 0 minus half, and this is equal to minus half. And when x is equal to 2, then t is equal to 2 minus half, and this is equal to 3 upon 2. Therefore, integral I, when x is 0, t is minus half, and when x is 2, t is 3 upon 2, and dx is equal to dt divided by square root of 17 upon 2 whole square minus t square. Now, we know that integral of dx upon a square minus x square is given by 1 upon 2a into log of mod a plus x divided by a minus x plus the constant. So, this integral can further be written as 1 upon 2 into square root of 17 divided by 2 log mod of a plus x. A here is square root of 17 divided by 2 plus t divided by square root of 17 divided by 2 minus t plus the constant, and this is from minus half to 3 by 2. This is further equal to 1 upon square root of 17 log mod of square root of 17 plus 2t divided by square root of 17 minus 2t plus the constant, and this is again from minus half to 3 upon 2. This is further equal to 1 upon square root of 17 log mod of, first substituting 3 upon 2. So we have square root of 17 plus 2 into 3 upon 2 gives 3 divided by square root of 17 minus 2 into 3 upon 2 again gives 3 plus the constant minus 1 upon square root of 17 log mod of square root of 17 plus 2 into, now replacing t by minus half, gives minus 1 divided by square root of 17. Now here we have minus 2 and multiplying it with minus half gives plus 1 plus the constant. So this is further equal to 1 upon square root of 17. Taking common, we have log mod of square root of 17 plus 3 divided by square root of 17 minus 3 minus log mod of square root of 17 minus 1 divided by square root of 17 plus 1. This is further equal to 1 upon square root of 17 log mod of square root of 17 plus 3 divided by square root of 17 minus 3 whole divided by square root of 17 minus 1 divided by square root of 17 plus 1, and this can be written as 1 upon square root of 17 log of square root of 17 plus 3 divided by square root of 17 minus 3 into square root of 17 plus 1 divided by square root of 17 minus 1. This is further equal to 1 upon square root of 17 log square root of 17 into square root of 17 is 17 plus square root of 17 plus 3 times square root of 17 plus 3 divided by 17 minus square root of 17 minus 3 times square root of 17 plus 3. This is further equal to 1 upon square root of 17 log. Now 17 plus 3 is 20 and this gives plus 4 into square root of 17 divided by 17 plus 3 is again 20 minus 4 square root of 17. Now taking 4 common from the numerator and denominator and cancelling, this gives 1 upon square root of 17 log of 4 we have taken common, so we have 5 plus square root of 17 divided by 5 minus square root of 17. Now further rationalizing the denominator, we have log of 5 plus square root of 17 divided by 5 minus square root of 17 into 5 plus square root of 17 divided by 5 plus square root of 17, and this is equal to 1 upon square root of 17 log of 5 plus square root of 17 whole square divided by 5 square minus square root of 17 whole square. So this is equal to 1 upon square root of 17 log of 25 plus 17 plus 10 root over 17 divided by 25 minus 17. So this is equal to 1 upon square root of 17 log of 25 plus 17 gives 42 plus 10 root over 17 divided by 8, and this is further equal to 1 upon square root of 17 log of, now taking 2 common from the numerator, we have 21 plus 5 root over 17 and denominator 8 can be written as 2 into 4. On cancelling, this is further equal to 1 upon square root of 17 log of 21 plus 5 square root of 17 divided by 4. Therefore, integral dx upon x plus 4 minus x square from 0 to 2 is equal to 1 upon square root of 17 log of 21 plus 5 root over 17 divided by 4. This completes the solution.